All right, so to create a list that's 5 entries long, or however many entries this is, we would just say num days times, right? Make a list for the sales for each day. Now this is what's called a parallel array. A parallel array is when we have 2 or more lists of the same length. Where the data is linked by the index, the subscript. Synonymous terms, right? So, say that we sold $200 on Monday, $100 on Tuesday, $50 on Wednesday, and then nothing on those days, right? Now, normally we'd perhaps prompt the user or read these from a file, but we could do sales.append, right? We sold $200 for Monday. First day, Monday, we sold 200, right? And then sales.append $100 on Tuesday. Second day, Tuesday, right? And then we sold $50 on Thursday. Excuse me, Wednesday, right? That's the third day. Whoopsie, where'd that come from? There we go. Fourth day, and then the fifth day, right? So now we could print out our sales and the days that they correspond to, right? Just with a loop. Now it needs to be an index-based loop rather than a for each loop. So we're going to use a range because we need to count an index through the numbers 0, 1, 2, 3, and 4. Right? So for I in range from 0 up to the number of days we have, right? Incrementing by 1. And technically I could just leave that part off, and I could leave that part off and it would behave the same, right? So that'll count from 0 up to 4 since our number of days is currently 5, right? And so we're going to print out the day, right? So days subscript I. That was supposed to be in curly braces. Where did my curly braces go? I thought I typed them. Guess I didn't. And then the sales, right? Subscript I. Because day 0 is Monday, sales 0 is 200, right? Days 1 is Tuesday, sales 1. So this is index 0, really, right? Just by dint of it being appended first and second and third, right? Right? Just like that. Makes sense? So now it may not look good, you know. I guess we could put a $sign in front of it, and we could say that we want, you know, 2 decimal places. I'm not sure if that's how you specify 2 decimal places. I don't recall. Let's run it. Why did it say that? Oh, I see. I forgot my closing curly brace, right? I had my closing curly brace there, but I didn't have it for that. All right, let's give it a shot. All right, precision not allowed in integer format specifier. Fine. What's going on there is that these are whole numbers, and so there's not going to be any decimals. So why don't we just get rid of that, right? That's not working very well. It's showing sales of $0 each day. Not sure why. Let's print out the sales array and the days array just like this, right? Print days, print sales. We'll see what those numbers are. Oh, I had already initialized the array full of zeros, right? My mistake. I should have just made an empty list and appended it to it, but I didn't. So we're just going to make an empty list instead so that we can append to it, right? Sales is equal to that. Make an empty list so we can append to it. If I wanted it to work the way that it was, I would have to do sales subscript 0 equals 200, sales subscript 1 is equal to 100, sales subscript 2 is equal to 50. And I guess that wouldn't take too long to do, right? It wouldn't take too long to change it, right? So sales subscript 0 equals 200, right? Subscript 1 equals 100. I'll come back and delete those parentheses. Sales subscript 2 is equal to 50. Sales subscript 3 is equal to 0. And sales subscript 4, right, is equal to 0. There we go. Let's get rid of those. All right. Right. So here we go, right? This is treating lists as though they're arrays. So we're not doing any appending. We're not changing the length of any of the arrays, any of the lists once they're allocated, right? That's one way to do it. What I probably would have done if I had not want to focus in on the fixed length arrays like I did here is use .append. And you saw me, go towards that solution. And so let's write a little application that asks the user for the height in feet of a list of people, right? So let's declare our list of people. People is equal to, we have 4 people in it, right? We have Alice, we have Bob, we have Carol, and we have Doug, right? There we go. And we're going to make an empty list full of height, right? Like that. This time we will append to the list. And this simplifies it actually because we don't have to calculate the length of the list, right? We don't have to calculate the length of the array. We just make an empty one and we start appending to it. So let's do that. For person in people, or for value in people, for every value in the people list, we're going to write a question out. Parentheses F quote, what is the height in feet of, curly brace, that value, question mark, space, end quote, in parentheses, right? Maybe put a little angle there to tell them where to type. Once we get that height, right, we got to get the height. Should store it in a variable called x, and then we'll append it, right? Like that, right? And then we append that to our height array. And then we're going to have another for loop that prints it out, just like the other one. So again, since this is a parallel list, this time we're going to need the index so that we can link that person's sales with that person's height. Once it's full, right? Once it's got, 4 numbers in it. And that person's sales with that person's height, and that person's sales with that person's height, and so on. So use a range-based for loop to display parallel arrays because we need the index subscript to link the items in the arrays, right? So that we have element 0 in one array and element 0 in the other, because they correspond to each other. Okay, so for I in range, the length of the people list, right? We're doing that just because since these are of the same length, it's okay just to use the length of either one, right? So why not just use the length of the people list? We could have made a variable called num people, right? If you felt like doing that ahead of time, num people equals len people, right? That'd work just as well. And then put num people there. But why create a variable if we don't need it? Let's get rid of that. All right. And so let's print that person. So people subscript I. And then let's print out their height, right? Height subscript I. Now this is going to look lame because it's not going to be spaced correctly. But we could fix that after we run it. Or not. Where's our syntax there? Up at the top? That's not true. It was running before. Missing quotes. Missing quote there. Mismatched parentheses. No, I'm not spotting the problem. All right, so what I'm doing to try to fix that is I'm just deleting part of the code, you know, and finding out where the error is. Is it this for loop here? I'm going to temporarily cut that and run it and see if the syntax error goes away. Yes, it does. So that means that the problem is in this last chunk of code. It's surely not the comments. No, it's not the comments. Of course it's not. Got to be in here. F quote. Oh. It could have told me, right? My mistake. Put the placeholders, you know, around each variable. We should have told me that specifically rather than saying that the error was at the top of the module. Anyways, what's the height in feet? She's 5'5", 6'6", 7'7", 8'8". These are some tall people. Doesn't look good. I kind of wish that these were, you know, that the input was actually happening on those lines. So I'm going to make a few changes. I'm going to cut this out and paste it inside the input statement so that our input is on the same line. Right? Guess we could get fancy and make a variable that holds that. So our prompt is going to equal that string, and then we will ask for that. Right? Like that. Or I could have left it as it was and just said, comma, end is equal to empty string. Like that, right? That means don't go to the next line. Now this is getting a little bit long. So what I'm going to do here is say x is equal to input. Just trying to write whatever will make this look clearest. Something happened. I've kind of garbled it. Comma, end is equal to, like that. And then we can ask for the input. There. I think that's clear. Print this line, but don't go to the next line, right? If we wanted to go the next line, we would not have an end parameter, or we would put \n there. Say we needed more information about the print command, we would just go to the Python shell and type in list print, right? Excuse me, dir print. All right, and it would tell us that it has some parameters, right? I thought it would list the well, I'm not seeing end listed here, so I would type in help print, right? And it would tell me a lot more stuff, like the end parameter. This is a string that's appended after the last value, but it defaults to being a new line. You can also specify the separator. If you want to print out a series of things and you want a separator to be different than a space, then you would specify SEP equals. If you want to save to a file, you do file equals. We don't want to save to a file. I think that we're perfectly good here. Let's go ahead and run it again. Right? And so what is the height of feet in Alice? Why, she is 5.5, 6.6, 7.7, and Doug is 8.8. Then it prints it out. Well, why don't we figure out, a good number of spaces to print out? So, maybe 10 spaces for the person's name, or 20 if we think that's what it needs. Then the question becomes, how would we calculate, the right number of spaces for the maximum length, right? We could go through the list and figure out the maximum length, of each one, and then we could record that. But let's just specify 20. And then we want the height to be printed out with 2 decimal places. So I put a 0.2 after the colon there. This means fill it with 20 spaces. This means fill it out with, I don't know, how tall can somebody be in feet? Nobody's more than 9 feet tall. So let's say, like if it was going to be 9.99, really probably 1 decimal place is enough. I am 5.5 feet tall. And let's leave it as 2. How wide is this? 1, 2, 3, 4. So we're going to say 4 spaces, but 2 of them are decimal places. Right. All right, so Alice is 5. Bob is 5'7'5". Right, Carol's taller than them, and Doug is 6 foot, like that. And that didn't work. Let's just try .2, like that, right? See how that looks? Doesn't look good at all. Alrighty, I think I need to put an F there to indicate that it's a floating point number. Five, 6, 7, 8. Unknown format F for object of type string. Now, what did I do there wrong? I forgot to convert it to a number, right? So X is equal to the float version of the input. So then it was trying to treat it like a string. It's possible that if I'd left out the, that I could leave out the F now, and it would work just as well now that these are floats. That was my understanding of it. I could be wrong. 5, 6, 7, 8, right? Okay, now it's playing one. Okay, so it's working like I wanted it to, but I could put the F there to force it to be a floating point number, or to specify to make it do a sanity check, right? But we know it's a floating point number because of that, so I'm going to leave that off, right? If I want it left justified rather than right justified, let's take a look at it and see what the output is and see if there's any more improvements we want to make to it, right? All right, like maybe we want the names to be over here and we want them to be left justified rather than, right justified rather than left. We want them on the right side. Let's figure out how to do that. So look up interpolated left or right justify Python. Come on, Stack Overflow, don't be so slow. Alrighty. Here's what it looks like if you do it the old-fashioned way. I'm sorry, that's kind of hard to read. Let's disable the Here's how it would look back before the invention of the formatted strings, where you put the F in the front. You specify the width like that. Okay, so you use a greater than sign to mean right justified. Let's try that. Yep, that's going to work, right? So let's come over here. And do that, right? Now this is almost starting to look too cryptic again, right? So I better add a comment as to what all that means. Maybe we should go back and format this one nicely as well, because we like to see dollars and cents in our output, right? So let's go up here, back to our prior for loop. Make it look a little bit better, right? So we're going to make it have 2 decimal places. Oh, we already ran into this. We already ran into the fact that these are integers. Why don't we make sure that they are floating point values using list comprehension? So sales is equal to the float of the value for every value in sales. All right. So that converts the list items to float using list comprehension. List comprehension is just when you use this syntax of putting square braces and you put a little for loop in here. Now we can do that .2f and it'll specify, you know, 2 zeros after the decimal place, like that. No, it won't. That looks real nasty. Doesn't that look atrocious? It's doing it in scientific notation. So let's go ahead and put the F back into place and see if specifying it like that prevents it from doing scientific notation. All right, there we go. And we might want them right justified, right? To line up by their decimal places. Let's do that. To right justify something, we put that. They didn't right justify it. Which might be just as well, because then the dollar signs would not be in the right place. But I wanted it to work, of course. Seemed to work here. I'm being too picky, but maybe because I didn't specify a width. Right, what's our largest number of sales? Let's say that our largest number of sales could be 9999.99. How wide is that? That's looks like it's going to be 7 wide. 1, 2, 3, 4, 5, 6, 7. All right. I'm not going to mess with trying to get the dollar sign to be right in front of them, right? Maybe I should just get rid of the dollar sign altogether. not looking good. And let's print a header, right? So print the day, right? Why? Come on. Followed by a space, and each day is 3 long, right? So that'll work. 1, 2, 3. And then the sales, but the sales occupies 7 spaces. So 1, 2, 3, 4, 5, 6, 7, but the word sales is 5 in length. So 1, 2, 3, 4, 5, sales. Well, that looks ugly. Let's just see how this looks. Might look good. I don't think that's going to look good. I think I wanted it to be 7 wide, and that's only 5 wide. 1, 2, 3, 4, 5. So I'm going to do that. Oh, come on. Where'd the rest of it go? Don't overstrike when I'm not planning on you doing it, right? And then we're going to want to print some underscores, right? And we can put a dollar sign up here, right? That'll help indicate that these are all dollars. Maybe a \n to separate the rest of this output, and that's actually looking just about absolutely perfect, isn't it? Right? So let's print a blank line. Let's do the same here, right? Let's print a blank line before we start asking for input. And then we get all of our input, and then we use a for loop. We might want to put a blank line here. Let's do a header, right? So print needs to be 20 spaces wide, but then we want the word person. The word person is PERSON 6 characters wide. So 1, 2, 3, 4, 5. Why aren't you where I want you to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I have a hunch that there's an easier way to do it than this, and then go back 6 for the word person. 1, 2, 3. Why is it going back in tabs? Okay, 20 minus. What kind of weird mode is it in now? All right, anyways, 20 minus 6 is 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then we add a space. And for height, we decided that we wanted, to allow up to 9.99, which is 4 characters wide. And then so height. That's too long, right? Because I only have 4 spaces to do. And then let's print our dashes. And I think this will look good. What's a height and feet of Alice? 5, 6.1, 4.8, and 7.25. That's a really tall person, right? And that's looking really stupid there. So why don't we just put dashes right under there? Let's delete all but those last 6, and then I'll stop being perfectionist about it. My mind is stuck on the idea of how we could use a formatted print statement to get that to look right. I'm going to give it a shot. We'd want it to be a formatted string. We'd want to print the word person, but that the word person is an actual thing like that, right? Or we could create our strings beforehand, right? The A string, or the header 1 is equal to the word person. Header 2 is equal to the word feet, like that, right? And so we're going to print out the value of header 1, but we want it to be 20 wide, and we want it to be right justified. and then we want to print out the second header, and we want it to be 4 wide, right? That way, if we ever decide to change its width, all we have to do is, I was counting 20 and then backspacing 6 and stuff like that. I don't know how I want to do it. Let's give that a shot, and then maybe I'll just comment it out, right? Because the first one's easier to read. Right? It did work. Okay, so I'm glad to know how it did work. I mean, that we could get it to work. Or we could print the header like this, right? That would take care of the top line of the header, and then we would need to do the same thing, right? The header 1 would now be 6 dashes, 1, 2, 3, 4, 5, 6, and then the header 2 would be 4 dashes, 1, 2, 3, 4, and then we would just use the same line to print it out again, right? Just like that. Okay. I think I'm going to make that green text with that kind of comment because it's easier to read. But the first way is probably easier to read, right? And clarity of reading is sometimes just as important as anything else. I don't know. If you get used to it. Okay, so we better explain what in the world those greater than things mean and those dot means. So, explaining format placeholders, right? F X prints the value of X, right? Without any format. X:4 prints X padded out to 4 spaces, right? F X:4, right, justifies the output. F X dot, X:4.1 specifies 4 digits or up to 4. Specifies 1 decimal place, right? A decimal point followed by a number, padded to 4 spaces, right? And so if we had X equal to 3, then in this case our output would have been just the number 3, right? And then here it would have been 3 followed by spaces, using underscores to represent spaces, right? And then doing it this way would have padded it out to 4. Whoops, should have been only 3 of those, right? 1, 2, 3, like that. And then doing it this way would make it look like 3.1, like that, right? And then the super duper one, combining it all. Greater than 4.1, right? Right justifies the above output, right? So that would look like space 3.1. Using underscores to represent spaces in the output. Again, this probably would have been better served by being all green text, right? So let's do that. Okay, hope that makes sense. Hope that makes sense. Because that looks pretty complicated, but we can take it apart. The greater than just means right justify. Let's go ahead and put the F there, right? One place, decimal place padded out to 4 spaces. Put the F there. All right. Don't put the F there if it's not a floating point number. If it's not a floating point number, you better not do that dot business either. All right, why don't we go back and look at the PowerPoint now? So construct lists and access items in those lists. So a list allows the programmer to manipulate a sequence of data values of any types. Whereas a dictionary, I'm not going to even talk about dictionaries, we'll go back to them. So for example of lists, you could have shopping lists, to-do lists, guest lists, right, or a recipe, names in a phone book, and every element in the list has an index number, right? It's subscript, it's index. It starts at 0 and goes out to length -1, right? So if the list has 4 items in it, you can access elements 0, 1, 2, and 3. So that could be a list, right? And you can even make a list that's got lists embedded in it. That's a little bit more complicated than my brain wants to think about, but this makes what's known as a 2-dimensional array, where the first row in it, like on a spreadsheet's got a 5 and a 9, and then the second row has got a 541 and a 78 on it. So here is a list containing the numbers 1, 2, and 3, and 4. Or you can use a range statement to create the same thing, right? Since 1, 5 makes a series of numbers 1, 2, 3, 4, you could use a range statement, pass that into the list function, right? And it'll build a list that equals the exact same thing. Very rarely do I need to create a list that's just a sequence of numbers, right? But you could do so. And by sequence of numbers, I mean, you know, a series 1, 2, 3, 4, or something like that, 10, 20, 30, 40. But I guess it might happen. If so, you can use a range statement. All right, so len will return the length of the list. Using the square braces lets you access the elements of the list. You can use the plus sign to add elements to the list. So if we have a list that looks like this, right, list is equal to red, comma, blue, and then we want to add 2 more colors to it, we can do this. Right? Append those 2 values to it. Or you could have just called L.append green and L.append purple, right? But let's say that we have a list that looks like this. L1 is equal to, you know, and it's got some numbers in it, 8, 6, 7, and then list 2 has got 5, 3, 0, 9, right? And then we want to make a list that's equal to those 2 things combined, right? So L is equal to L1 plus L2. Like that. Then if we printed it out, it'd say 8675309, right? So concatenate the lists, right? Or append, create a new list that is, right, the other lists joined, right? Whatever. Just add those two to the list together. Concatenate one to the other. So there we have 8675309. So we could do L is equal to 100 times, 0. Create a list that is 100 elements long. Each one equals a 0, right? L is equal to that. Make an empty list. Ready to be appended to, right? To check to see if something is in a list, you can use the IN keyword, right? So, if I want to see if there is a 7 in my new list, my 8675309 list, I could check, right? If 7, why did I type 8? Well, I guess there's an 8 as well, is in L, well, that'd be bad. Why don't we just call this Jenny? Because of the old song, Jenny's phone number is 8675309. There we go, right? And so if there's a 7 in Jenny, then print, yes, found a 7. Else colon, print, no 7 found, right? That's what the in keyword does. You can replace an element in a list. A list is mutable, meaning that you can change elements in it, and that's unlike a string. This would be a syntax error. S is equal to ABC, and then saying S subscript 0 is supposed to be a Z instead. Syntax error. You can't change pieces of a string like that because strings are immutable. Immutable meaning unchanged, right? That's what mutate means, change. But you can in lists. So we have Jenny's phone number. We want to change the first digit in her phone number from an 8. It's going to be a 2. For some reason, there's no 2 in her phone number, and we want it to be 2, right? So now her list is, it was 8675309, but now is 2675309, right? Change the first element. All right, I'm going to switch gears for a moment and talk about dictionaries. You create a dictionary like this. I'm just going to call it capital D. Like that. What is a dictionary? A dictionary is a data structure that links keys to values. If you also wanted to do it like this, you could do it like that, I think, but this is a pretty clear syntax, isn't it? Dictionaries list keys to values, right? Or links, sorry. What does that mean? Well, like if you open an English dictionary, the keys are the words and the values are the definitions, right? So D subscript, an int is equal to a numeric value with, what is the definition of an int? That is a whole number, right? And then what is the definition of a float? A float is a numeric value with a decimal point, right? Yeah, these are not dictionary ready definitions or whatever, right? And what is a dog? A dog is a mammal that says, is that how you spell mammal? That barks a lot. Stupid, right? And then what is a cat? A cat is a mammal that uses a litter box, that meows a lot, that eats cat food. There, right? And so what we've done is we've created our dictionary. Now, a dictionary doesn't have to be words, right? Dictionary could be anything. Like it could be days of the week in sales, right? A dictionary for, containing Monday, and their sales are, 200. Tuesday's sales were 100. And Wednesday's sales were 50. And then after that, it was all gone, right? But let's make a new dictionary for that, right? Sales is equal to empty dictionary. And then sales, right? And so we see how to access those things. And so if we want to print out the definition of an int, we can do so easily, right? Print out the dictionary for the int. Like that. Print out the dictionary for a dog. Now these are not placeholders, right? I'm just actually printing out the value. We're accessing that, or we could just do this, right? A is equal to the dictionary for cat, and then we could print out A, right? Makes sense? And then we could print out the sales for Monday and Tuesday and Wednesday doing the same kind of thing. Now for sales, I probably wouldn't use a dictionary because these are not necessarily stored in order. If we printed out the dictionary, we would not necessarily get these elements in the same order that we appended them to. But let's print out the sales dictionary, right? And let's print out our, the other dictionary, the one with dog and cat in it. I forgot my equal sign there. Alrighty, fix that. Five, 6, 7, 8. All right. And so the dictionary for Monday, Tuesday, and Wednesday shows that Monday corresponds to 200. Tuesday corresponds to 100. Wednesday corresponds to 50, right? And then we see that an integer is a numeric value. That's a whole number. And a float is a numeric value with a decimal point. And then a dog is a mammal that barks a lot, right? What if we wanted to print out their keys and their values? Iterate through dictionary keys Python. Well, let's give that a shot. Let's try for state or for value in dictionary, except we're going to say for key, right? So for key in the dictionary, print out the key. And it's going to say, int, dog, cat, and float. Right? Int, float, dog, cat. That's the order in which we inserted them. So they happen to be in the correct order, but there's no guarantee that they'll be in the correct order. And by correct order, what if we wanted to alphabetize it, right? So anyways, but we also want to print out the thing's value, right? So the key, quote, means, end quote, or definition is, end quote, comma, the dictionary for that key. Let's do the same thing for sales. For key in sales, we're going to print the key, or how about sales for, end quote, comma, key, quote, comma, R, end quote, comma, sales for that key. So 5, 6, 7, 8, right? And then so the int definition is a numeric value. The float definition is a numeric value. Looks like I tacked on an extra space that I don't want there. Cat and a dog. Sales for Monday are sales for Tuesday are sales for Wednesday. So you can see what a dictionary is. It's just a collection of key value pairs, right? Is a set, that's not correct, collection of key value pairs. Another way of saying it, right? And we've given several definitions of that. So our homework for this, write a program that asks the user for rainfall for the months in a year, right? January, February, March, etc. Example, right? What was the rainfall, or what is the rainfall for January? And you type in 10 inches. What is the rainfall for March, right? You type in 20 inches, or 12.2. What is the rainfall for January? Why didn't I say Feb? For Feb, 8.1, etc., etc., right? And let's put February in the correct order. The program then prints a report, right? That looks like this. Rainfall table, month, followed by inches, right? And then so for January, it was 10.0, right? For February, it was 8.1. For March, it was 12.2. Not totally satisfied with the way that looks, but I guess that's good enough, right? If you don't want to do abbreviations, that's fine. We have two examples in the notes of this. One was for daily sales. The other was for, what was it? People's heights in feet. All right, hope that makes sense. All right, I'm going to end the lecture here, and we'll pick up next time. finishing it off and talking about classes as well, how to create our own class, because we've been using other people's classes here.